the tangent function. Thanks for watching this video, and don't forget to like, subscribe to the channel and activate the notifications. It is very important to the continuity of this channel. The value of the tangent of an angle theta is the slope of the line passing through the origin and the point P on the unit circle. You can think of it as the slope of the terminal arm of angle theta in standard position. Consider the unit circle diagram given. P is a point which is free to move around the circle. The tangent ratio is the length of the line segment tangent to the unit circle at the point A from the x-axis to the terminal arm of angle theta at point Q. As P moves, so does Q. Q's position relative to A is defined as the tangent function. To graph the tangent function, the horizontal axis shows the values of theta and the vertical axis shows the values of tangent of theta. We project the values of tangent of theta from the unit circle to the set of axes to get the graph of tangent of theta. Recall that tangent of theta equals sine of theta divided by cosine of theta. Whenever cosine of theta has a value of 0, the tangent function is undefined. Vertical asymptotes are vertical lines which correspond to the zeros of the denominator of a rational function. Therefore, the tangent function has a vertical asymptote whenever cosine of theta is 0. To get of the tangent function, we plot points as we did for the sine and cosine functions. The tangent of 0 radians is 0. The tangent of pi over 6 is 0.58. The tangent of pi over 4 is 1. The tangent of pi over 3 is 1.73. The tangent of pi over 2 is undefined. The tangent of 2 pi over 3 is minus 1.73. At 3 pi over 4, it's minus 1. The tangent of 5 pi over 6 is minus 0.58. Then, back up to 0 by p radians. From now on, you should notice that the values of the tangent function are repeated. We can see that, like the sine and cosine functions, the tangent function is also periodic. Unlike the sine and cosine functions, however, the period of the tangent function is pi radians rather than 2 pi radians. Joining the dots as neatly as we can, we get a smooth curve. Pay attention. Feature of tangent graph. Range. The range is the set of all real numbers. The domain of the tangent function is the set of all real numbers, except those in which the function is not defined. The period is 2 pi radians. amplitude. The graph has no amplitude because it has no maximum or minimum values. We have just learned to draw the standard tangent graph. We now consider some of the possible transformations that can be applied to the standard tangent function and look at how these transformations affect the basic properties of this graph. The general tangent function is the name given to any curve that can be written in the form. For tangent functions, there is no concept of amplitude, since the range of the tangent function is the set of all real numbers. The role of a in the tangent function is to provide the magnitude of the vertical stretch. The number b in front of theta minus k affects the period of the function. The number k is the horizontal shift, may also be called phase shift. If k is positive, the horizontal shift is to the right, and if k is negative, the horizontal shift is to the left. The number c is the vertical shift. If c is positive, the vertical shift is up, and if c is negative, the vertical shift is down. Sketch the graph of the function. We start by comparing the function given with the general tangent function. But in this particular function, there is a 2 multiplied on the variable. So we need to factorize out the 2 that is multiplied on the variable to rewrite this function in the general tangent function form. We now see that a is 4. There is no vertical translation. And the value of b is 2. So the period is pi over 2 radians. K equals 3 pi over 4. So this is the horizontal translation. Draw the Cartesian plane. The first cycle begins at the 0 point k units to the right of the origin. K is 3 pi over 4. A period of the tangent function has 2 asymptotes and a 0 point halfway in between. So place a vertical asymptote pi over 4 units to the right of the beginning of the cycle, and place a vertical asymptote pi over 4 units to the left of the beginning of the cycle. The y value of the point halfway between the 0 point and the right asymptote is a. The y value of the point halfway between the left asymptote and the 0 point is minus a. Draw a smooth curve through the 3 key points, approaching the asymptotes on each side. This will produce the graph of one wave of the function. Duplicate the wave to the left and right as desired.